All right, so last time we finished up section 4.2. I think we had split that into 2 days to just go through it a little slower. And that was on graphing. So remember, we graphed functions that had like horizontal asymptotes, vertical asymptotes. I think we did one with a slant asymptote as well. So we focused mainly on graphing. This section is going to focus mainly on solving equations. So we're going to go back to really algebra and just solve equations. If there's anything that we can't solve algebraically, maybe like some of the inequalities we do, we'll do them on the calculator. All right, so let's take a look. Right, so we're going to be solving equations that basically have fractions in them. So let me kind of just skip ahead and show you a problem. Okay, that's the kind of equation we're going to solve today. Right? And the real trick to solving them is going to be the fractions are what make them complicated. So how can we get rid of the fractions so we don't have them anymore? That's what I'm going to show you how to do. All right. So the first problem we're going to start off with is it's a distance problem, and it uses the formula distance equals rate times time. So if you don't remember that formula, distance equals RT, put it up there. And we'll use that to do the first problem. And if you want to put that like on a reference sheet, for this week's test, you can put it on there. That I would remind you what it is though if you forget it, because I'm not really teaching you what the formula is. I'm more interested in you like setting up an equation and solving it. All right, but it's a good formula to try to remember. Okay, so what's basically going to be happening here? So this person is going to be taking a trip, and they're using 2 modes of transportation to get where they're going. One mode is a car, the other one is a train. And then they give us some information about each mode of transportation. The goal is going to be to find out how fast the car is going and how fast the train is going. They don't tell us that. But what they do tell us is that Sue drove 30 miles in her car to the train station. And the total length of her trip, including what she traveled by car and train, was 120 miles. We don't know the exact speed of the car or the train, but we know on average the train is 20 miles an hour faster than the car. So all we're going to do in this part is write a formula. Okay, we're not even going to solve anything. That'll be the next problem. And the 2 things that we don't know are the speed of the car and the train. Well, we have to pick one of them and let it be the variable. It doesn't matter which one we pick. Right? It just changes kind of what perspective you're doing the problem from. We're going to do it from the perspective of the car. Okay? So since I don't know the speed of the car, how could I represent it for now? Let's see. Yeah, we could use C for the speed of a car. We're going to get into a little bit with graphing. Nothing wrong with C. But if I'm going to do graphing in a problem, we might want to use a letter we're used to with graphing. So we'll use X to represent the speed of the car. So we're going to find a formula that represents the time it takes for her to do the trip, depending on the speed of the car. And of course, once you know the speed of the car, and you know the train is 20 miles an hour faster, well, then you can figure out the train too. So capital T is going to represent time. Okay, that's the time for her to complete the trip. Now, how many different modes of transportation is she taking? 2. So she's spending some time in the car, and she's spending some time on the train. So the total time is going to equal, we got to take the time that she spends in the car. You got to take the time she's on the train. And what do we have to do with the two of them?
Add them.
We have to add them together. So that's kind of the big idea of what we want to do. Come up with a formula for the total time. And total time, I'm going to abbreviate it as capital T. And it's going to be a function of x. So T of x. And what does x mean? What does x represent again?
Speed of the car.
It's the speed of the car. All right, so let's figure out a formula for the time she's in the car. We have distance equals rate times time. So off to the side, I'm just going to write that down. What if you solve distance equals rate times time for t? What would be on the other side?
Distance divided by rate.
Right. That's how you calculate time. You take the distance and you divide by the speed, and that gives you the time. So let's do that for the car. We're trying to find the time that she's in the car. So we're going to take the distance she traveled in the car, and we're going to divide by the speed of the car. And that gives you the time of the car. So what's the distance that she traveled in the
30
car?
miles.
30 miles. So there's your distance. Now divide by the speed of the car. How fast is the car going?
X.
X. That's the time in the car. 30 divided by X. All right, now I'll do the same thing for the train. They don't give us the distance the train traveled, but we can figure it out. What's the distance that the train traveled?
90 miles.
90, right? We know the total trip is 120. She did 30 in the car, so the rest must have been on the train. So there's the distance on the train, and now divide that by the speed of the train, and that'll give you the time of the train. So what's the speed of the train? X plus 20. Yep. And for this problem, that's all I wanted. That's an algebraic expression for the time it's going to take to complete the trip. Any question on that? Now, we have two separate fractions with different denominators. It is going to be helpful to put them together with a common denominator for part of the next question. But for now, we can leave it like that. So we'll come back to that formula. And now they want us to use that formula to just figure out a few things that we looked at last week. Any asymptotes where it crosses the x-axis, the EBM and behavior model, and then we'll sketch it on the calculator. Okay, to find some of those things, it's better to have that all together in one fraction. What do you always need to have if you want to take two fractions and put them together as one?
Like denominators?
Yeah, you got to have the same denominators. Okay, do we have the same denominators here?
No.
No. Well, here's an example with numbers. If you wanted to add these two fractions together, what's one way to get a common denominator between 5 and 4?
Do the same to the top and the bottom.
Yeah, if you just multiply them by each other, it will give you a common denominator. So here it would be 20. Here it would be the first one times the second one. So it would be, yeah, so you could write it as just x plus 20. Or you could write it out as x squared plus 20x. I'm just going to leave it as x plus 20 for now. Okay. So this denominator already had the x. What is it missing to make it have common denominator?
The x plus 20.
It's missing the x plus 20. So the way you find the common denominator, you multiply the top and the bottom by the x plus 20. Okay, and we'll do that in a second. Now this one has the x plus 20. What's it missing? It's missing the x. So you multiply top and bottom by x. Okay, in the first one, that 30 times x plus 20, that's distributive. What's 30 times x?
30x,
So 30x, and then 30 times 20.
600.
Okay, so I'm just going to put that here for a second. So that's 30x plus 600. And then there, it's not really even distributive. It's just multiplying 90 times x. So 90x. Now, when you combine 30x and 90x, what do you get?
120x.
120x. Yep. Okay, so there's the problem all with one fraction. And again, the reason I did that, it's going to help us to answer some of the questions. Okay, let's start with the EBM. Remember, the EBM is the highest degree term in the top, and divide by the highest degree term in the bottom.
So you want x over x squared?
Right. When you look at it separate, there's no 120 in this at all. But when you put it together, you can see that there is. So the highest degree term in the top, when you combine it, that's the EBM of the top, 120x. Now the EBM of the bottom is the highest degree term if you multiplied that out, and it would be an x squared. And what can I cancel out there? The top x and one of the bottom x's. So what is that? What's that going to leave me with?
120 over x.
Yep. Okay, so there's your EBM. Now we can use the EBM to find the horizontal asymptote. The horizontal asymptote is when you look at the EBM and you let x get really big. So what happens to the number in this box as x gets bigger and bigger and bigger? Well, something has to happen because there is an x in the box.
It's close to 0.
It's going to get closer to 0. So the bigger you make x, the bigger it makes the bottom of the fraction. And the bigger the bottom of the fraction gets, the smaller the whole fraction gets. So that's going to get closer and closer to 0. When you write a horizontal asymptote, we always use a certain letter for horizontal. Y. So horizontal asymptote is y equals 0. Let's do we can try vertical asymptotes. Okay, vertical asymptote, that's where the denominator would equal a certain number. Does anyone remember what the denominator equals for a vertical asymptote? 0. And vertical asymptotes do not start with y equals. They start with x equals. Kind of gave you a hint. There are two. There are two numbers you could plug in for x that would make the bottom 0. Does anybody see one number? Yeah? 0. Yeah. If you plug in 0, 0 times anything is 0. And there's one other number you could plug in that would make the other factor in the bottom 0. Yep.
-20.
-20. Now remember, x is the speed of the car, so I'm not saying -20 makes sense, but that wasn't the question. The question just said find the vertical asymptotes. Okay, so we found it. Okay, so horizontal, vertical, the EBM. Okay, and the zeros. When we talk about a 0, what does that mean on the graph? 0 is where the graph does what?
Crosses the x-axis.
It's where it crosses the x-axis. Okay? So think about where a graph crosses the x-axis. We don't know the x value of that. I'm not sure what it is. We do know the y value. What's the y value anytime you're looking for a root? It's 0. So remember, the way you find a 0 is you set the y value equal to 0, and then solve. Let's look at our equation. Well, there is no y up here, but there is something up here that means y. What in this formula means the letter y? It's just a different way of recognizing it. T of x. That's your y right there. So to find the root, change that to 0, and then solve. Okay, let's try it. 0 equals, and use the version that's all combined together. That's going to be a lot easier. 120x plus 600 over xx plus 20, I think. Okay, so you're basically setting a fraction equal to 0. There's only one way that a fraction can ever come out to the number 0.
If the numerator equals 0?
If the numerator is 0, it doesn't matter about the denominator. Just if the numerator comes out to 0, then the whole fraction is 0. So all we have to do is solve that. Okay, what would be your first step? Subtract the 600. Yep.
And then divide by 120.
Divide by 120.
-5.
And we get -5. Again, does it make sense if x is the speed of the car to have -5? Probably not. But we're not interpreting it in terms of the context of the word problem. We're just finding some stuff out about an equation. Okay. Any question on finding the zeros?
So when you write the 0, would you write x equals -5?
You could write it as x equals -5, or you could write it as -5 comma 0. You could write it as a coordinate. Just depends on what they ask. Yeah. But that's where it crosses the x-axis. Okay. Now we'll draw a picture. Yeah.
Can you explain again why the denominator doesn't matter?
Because I can have 0 divided by anything, and the answer is always 0. It doesn't matter what's in the bottom of a fraction. If 0 is in the top, it's going to come out to 0.
So you just top 0 to be able to solve it?
Yep.
Okay.
The only caveat to that is if you have 0 divided by 0, well, then that's undefined. That's a little different. But that's not what's happening here. Okay, so let's sketch it. We know we want to go to at least -20 on the x-axis. I'd probably go a little further, maybe negative 40. So let's get our window set. So -40. Now x max would be the speed that the car goes at fastest, its fastest speed. We don't have a limit that they really told us, so we'll set it to 70. And then for y min and max, I would just make it symmetrical. If you do maybe -25 and 25. Now, how many vertical asymptotes did we have? 2. Remember, when you draw 2 vertical asymptotes, how many sections of graph do you get? 3. You get a left, a middle, and a right. So we should see 3 sections. I don't think I typed in the formula yet. I'm going to type in the combined one because that's going to be less parentheses I have to deal with. So I'm going to do 120x plus 600. And I'm going to distribute the bottom so I don't have to do an extra set there either. So I'm going to do x squared plus 20x. So that's how I'm going to type it. So we'll hit graph, and let's see if we have 3 sections. Okay, well, there's 1. There's the left. There's the middle. There's the right. So we got all 3 sections. Okay, so let me put the graph here. Let's put the window that we used right there. And that's a complete graph. Not the only complete graph, but I'd say it looks pretty good. Now, out of those three pieces, the left, the middle, and the right, which piece would you be focusing on for the word problem? The right piece, right? We'd be focusing just on the piece in quadrant 1, which basically is showing as the speed increases, the time decreases. So the faster the car goes, the closer and closer that the time gets to this horizontal asymptote. And what was the horizontal asymptote?
0.
0. Will that line ever reach 0 as you keep going to the right?
No.
No. And just from the word problem, it doesn't make sense that it ever could. Because you can't instantly travel from one place to the other in 0 amount of time.
Not yet.
Not yet. So it has to take some amount of time to travel from point A to point B. Okay. Any question on that? So what we want to do now is let's set our graph up so that we are just looking at quadrant 1. Because this question is now looking at the graph again, but just thinking about it in terms of the word problem. It says Sue has 2 hours to complete the trek. Find the speed she must travel at. We're going to do more algebraically later, so let's just do it graphically for now, and we'll do some algebra later. So here was the formula. I think it was x squared plus 20x. I think. So it's giving us a number, okay? It's telling us she has 2 hours to complete the trek. So we have to decide where that 2 is going to go. Does the 2 get plugged in for x, or does it get plugged in for t of x? Right, 2 is a time. X is the speed of the car. So they're not giving you speed, they're giving you time. So we're going to take that, and we're going to fill that in. Right there. Now, I already have the right side in y1. So what do you think I want to put in y2? Have a guess what's going to go in y2?
Y equals 0, so you can do the intercept. Okay.
Well, I can tell you it never will hit 0 because that's a horizontal asymptote.
Right.
So if you put in 0, that's a line that you'll never reach. What line is it that we want to reach? Yeah? We want to reach the time of 2 hours. So we're going to put a line in at 2 and then see what happens. Negative speed, again, that doesn't make sense. And neither does negative time. I don't think we need the y max quite so high. I mean, she's only traveling 120 miles. I don't think it's going to take anywhere near 25 hours to go that far.
She might be walking.
She could be walking, yeah. But we know she's on a car, so. And a
She's
train.
doing Fred Flintstone rules.
Yeah, she could be. Yeah, maybe it's a Fred Flintstone car. It's a slow car. All right, so there's the time it's taking. It's decreasing as she goes faster. There's the 2 hour mark. And what do we want to calculate there? Yeah, we're going to find the intercept. I should have asked, but did the guess matter?
No.
Clearly not, because I just hit enter 3 times. But it only crosses 1 time. We know it would cross further to the left. If you go back and look at the graph, it does cross in the negatives. But when it crosses in the negatives, that doesn't make sense. It is a solution to the equation, not to the word problem.
Is the calculator ignoring it because it's not in the window?
Correct, it's off the screen, yep. That's why we kind of simplified the calculator's life a little bit, so it didn't even have to think about the negatives, and we said just look at the positives. And it's going to take about 46. Well, it's 46.46. That's the speed of the car.
Is she on a back road?
What's that?
Is she on a back road?
Is she on a back road? I don't know, maybe. 46.46 miles an hour. Well, remember, that's the speed to complete the trip in 2 hours. I mean, maybe she completes the trip in a different time, but we're just saying, what if she did it in 2 hours?
That'd be so irritating going 46 miles per hour for 2 hours.
Yeah, 46, not 45. They go 46.
No,
No.
46.46.
46.
Yeah.
Now, what's the speed of the train?
It would be 66.46.
Right, the speed of the train would be 66 miles, 66.46.
Cargo.
And always make sure you look back and find what did they want you to find. They asked for the speed of the car. Okay, if they did the train, I would have written 66 instead of 46. 0.46. Okay, so any question on that one? Yeah.
What was the other one?
What was Y1? Y1 was this formula right here, 120x. Y2 was 2. Horizontal line at 2. Okay, don't clear that because we're going to come back to this problem and we're going to do something else with it. But we're going to look at a few things algebraically now. All right, so we didn't actually do this because I did it graphically, so I'm going to change what this says a little bit. Just going to reword it. But when we start to solve these algebraically, what we're going to have to do is we're going to have to multiply by variables. Whenever you multiply by a variable, you have to be careful. So I'll put when solving a rational equation. It says equation. If you multiply both sides, let's change that to of. If you multiply both sides of an expression, and let's just put the word by a variable. Okay, let's see if that makes sense now. When solving a rational equation, if you multiply both sides by a variable, comma, this can result in an equation that's not equivalent to the original. Basically, it's not equivalent to what you started with. And I'll show you what I mean. So if you multiply both sides by a variable, what you can do is you can end up creating an answer in the problem that shouldn't be there. And the only way to find out that it shouldn't be there is to check your answer. This solution that you created that shouldn't be there, it's not because you did something wrong, it's kind of a side effect of the method that we're using to solve the equation. But this is how you have to do it. That extra answer that needs to be ruled out is called an extraneous solution. So an extraneous solution is a solution that you created as kind of a side effect of the way you solve the problem, but it doesn't actually work if you plug it back in. So, check your answer. And I'll show you an example of that with kind of a simple equation. So if we look at the equation x plus 2 equals 0, what's the answer to x plus 2 equals 0? Negative 2. Does anybody think that there is another answer besides negative 2? No. That is the only answer to the problem. Now, let's say you tried to solve this a little differently. You wouldn't do what I'm about to do on this one, but you're going to have to do it on the next ones that we try. But I want to show it to you on a simple one first. Let's say that you multiplied both sides by x. That would give you an x squared, 2x, and a 0. Does everyone agree that I multiplied by x correctly? X squared, 2x, and then x times 0 is 0. Okay. Now, what do both terms on the left have in common?
X.
An x. So let's factor it out. Okay, so if you factor it out, you're left with x times x plus 2. Now there's two answers there that would give you 0. What number could you plug in right here that would make the second factor 0?
-2.
You could plug in -2, and that's the answer, that's the solution to the original. And what number could you plug in here?
0.
0. 0, let's try it in the original problem. Does 0 plus 2 give you 0?
No.
No. We didn't. When we multiplied both sides by x, we did it right. And when we factored the x out, we did that right. Because we multiplied both sides by x, we created an extra answer in the problem. Extra answer we created is the number 0. It doesn't work. Okay, that would be called an extraneous solution. Now I know we never solved this problem by doing what we did, but we are going to do that in the next problem. All right. So the goal, try to get rid of the fractions. The only thing that makes this problem more difficult than other things we've done is because there's fractions in it. If we can get rid of them, it's going to turn into problems we've already done before. I'm going to show you how to do it with numbers first, and then we'll jump into one that has letters, okay, in the bottom. So here's one with numbers. Let's say we had 1/3 plus 5/4 equals x over 12. The only thing that's making that a little difficult is all the fractions. The goal is to try to multiply everything by the LCD, okay, least common denominator. Does anybody see what the LCD is of 3, 4, and 12? 12. And I'm going to think of 12 as 3 times 4. Okay, 3 times 4 is 12. But let's just think of it as 3 times 4. So let's multiply this by 3 times 4. Multiply that by 3 times 4. And multiply that by 3 times 4. In each term, something is going to cancel out. The first one is 1 divided by 3 times 3 times 4. What cancels out in this first one?
3.
The 3. Divide by 3 times 3. How about the second one? 4. And what about the last one? 12. The whole thing cancels out. And the reason the whole thing canceled out is because this number on the right was the product of the two that were on the left already. And that's going to happen in our problems. That's why I did it that way. Okay, now let's just look at what we have left. What's 1 times 4?
4.
So now we have 4. And then 5 times 3?
15.
15. And then what's left on the right side?
X.
Just x. Oh, the answer is 19. So a very easy equation to solve if you get rid of all those fractions first. X is 19. Any question on what we did there? All right, let's try the same thing. Except now, the denominators aren't numbers. They're numbers and letters. Okay, and we already did one graphically, right? If I was going to do graphically, I just put one side in y1, put the other side in y2, and then look for where they cross. Let's try it out way. First thing I want to check is I want to see if this denominator on the right is really the product of the two that are on the left. If it is, it makes the problem a lot easier. What can I do to the denominator on the right to see if it really is the two on the left? Yeah, let's just factor it and see what happens. Okay. What would be your first term in each parenthesis? Yeah, it'd have to be an x. And you've got a negative in the middle and a positive constant. What does that mean about your signs? They both have to be negative. And now we need two numbers that multiply to give you 3.
3 and 1.
It's got to be a 3 and a 1. So is the denominator on the right the product of the two on the left?
Yes.
Perfect. All right, now we're going to multiply everything there by the least common denominator. It's going to be pretty similar to what we did up above. What's the least common denominator this time?
X minus 3 times x minus 1.
Yeah, it's the x minus 1 times the x minus 3. And they're all going to get multiplied by that. So x minus 1, x minus 3, x minus 1, x minus 3. And now cancel out what you can in each term. TJ, in the first term, what's going to cancel out?
The x minus 1.
Yeah, the x minus 1 is gone. Okay, we'll worry about what we have left in a minute. Landon, what's going to cancel in the second term?
The x minus 3.
The x minus 3. And what about the third term? Or the one on the right? Yeah.
The x minus 1 and x minus 3.
Yeah, the whole bottom. Because that is that. So what does that leave you with on the right side? Yep. Just a 2. The 2 on the right. And now, yeah, we got to do that on the left. So what's 2x times x minus 3?
2x squared minus 6x.
And you're going to see it's going to turn into an equation that we've done a lot. Okay, so it's 2x squared minus 3x. Now, in the middle, nothing's really going to happen because that's what you're distributing, plus 1. So what do you get when you distribute positive 1? 1x minus 1. So
Shouldn't the first have been minus 6x?
did I copy it wrong? Thank you. Yeah. Yeah, I did that wrong. Thank you. So 2x squared, then minus 6x plus x minus 1. I'm just going to move the equals to a little closer. Okay. Now we've gotten rid of all the denominators. What kind of equation is that?
Quadratic.
It's a quadratic. And when we solve a quadratic, what do we always try to get it equal to?
0.
There you go. Let's get it equal to 0. So 2x squared. What's negative 6x plus 1x? Negative 5x. And how would you move the 2 to the left side? Subtract it. And what's that going to give you for your constant? Minus 3. Negative 3. Okay, I think that's going to factor. If it didn't factor, we could try to solve it with quadratic formula. But that is going to factor. Okay, what does our first term have to be in each parenthesis? A 2x and an x, yep. What about your signs? You have a negative in the middle and a negative constant. One would be negative, one would be positive. I would try them in that order. If it doesn't work, you can always just switch it. And now two numbers that multiply to give us 3. We just did that up above. 3 and 1. Okay, so if we check that, we're going to get, oh wait, no, that might work. Negative 6x plus 1x. Is that what we want? Yeah, negative 6 plus 1 is negative 5. It's perfect. Okay, so that's the hard part. We factored it. Now, what do we do with each one of those factors?
Set them equal to 0.
Set them equal to 0. Okay, so the one on the right, we give you x equals 3 as a potential answer. You gotta check it. And what about the one on the left?
Negative 1/2.
Negative 1/2. Now, when we solve this, we did multiply both sides by something with a letter. So we need to make sure we didn't get an extra answer that shouldn't be there. Let's check 3. Let's go back up. And to check it, I'm just going to move these so you can see the denominators. Just plug 3 back in. Is there anywhere that you can't plug 3 in?
X minus 3.
Right, we can't plug it in for x minus 3. How come?
Because of the equals 0.
Right, it will cause us to divide by 0. If you get an answer that would cause you to divide by 0, you just throw it across the screen. You cross it out. That's an extraneous answer. It's a solution that we created because of the process we used to solve the problem. It does not work. Extraneous answers for these problems will cause you to divide by 0. That's what happens. Negative 1/2. Is there anywhere you couldn't plug negative 1/2 in the bottom? Well, what number are you not allowed to plug in here? 1. How about here?
3.
And then how about here? 1 and 3. So, is negative 1/2 a number you cannot plug in? No. That's fine. So that one will work. So there's really 3 things that can happen when you solve a quadratic like this. You can get one answer works, one answer doesn't. You could get both answers work. Or, what do you think the third thing is? Neither answer works. Both answers are extraneous and the problem is a no solution. That's the 3 things that can happen. Any question on that one? Okay. So let's try one more that's pretty similar to it. Okay, it says solve algebraically. And it's x minus 3 over x plus 3 over x plus 2 equals negative 6 over x squared plus 2x. Now right away, I just want to look at it and figure out what numbers are you not allowed to plug in for x. 0, yeah? And negative 2. When we solve this, if we get 0 as an answer, or we get negative 2 as an answer, those are extraneous. Are we going to get those as answers? I don't know. But if we do, we have to cross them. Yep.
Is it possible for all answers to be extraneous?
Yes. Yep.
What do you do if all is extraneous?
You just label them both as extraneous and write there's no solution. Yep. Okay. Let's factor the left-hand side and make sure that it is the product of the 2 that are on the other side. So I'm sorry, factor the right side. What do x squared and 2x both have in common? X. If you factor that out as a GCF, what's left in the parentheses?
X plus 2.
Are those the 2 factors? Well, are those 2 factors the denominators on the other side?
Yep.
Yeah. So we're going to solve this pretty similar to how we did the last one. Okay, what is each parenthesis going to get multiplied by? X plus 2. Yep. xx plus 2, xx plus 2, and now cancel out what you can in each spot. What's going to cancel in the first fraction? X. Okay. How about the second fraction? X plus 2. And the third one? The whole denominator, yep. It's pretty much how it works every time. Okay, so we get a negative 6. Don't copy that wrong. Now on the left side, in the first fraction, we have x minus 3 times x plus 2. That's two sets of parentheses we have to multiply together. What's the word that some people use to remember how to do that? FOIL. Yeah, the FOIL. So we're going to get x times x, which is x squared. We're going to get x times 2. So it's a 2x. And then an x times negative 3. So we can put those together right away. What's 2x and a negative 3x? Negative x. And then negative 3 times positive 2. Negative 6. Now here, make sure you always grab that sign with that number. So it's a positive 3 times x. So it's just plus 3x. All right. What can I do on the left side?
Combine like terms.
Yeah, we can at least combine like terms. And what does that give me when I combine my x terms together? 2x. Now it's a quadratic, so we want to make sure we get it equal to 0. And how would you move this negative 6 over? You'd add it. So that's gone. And that's gone. So the constant canceled as well. So now we have x squared plus 2x. And that's going to equal 0. And what can you do on the left-hand side? Yeah. And what can you factor out of both of them? And what does that leave you with? X times x plus 2. Okay, now we figure out each number that would make this 0. What makes the first factor 0? 0. And what about the second factor? Negative 2. But when we look back at the original problem, what did we say about 0 and negative 2? They can't be the answers. So when we solve this one, we got two answers that don't work. These are both extraneous. Doesn't mean I'm not going to ask you for them. I might give you a problem and say I want you to solve it. Hint, one answer is extraneous, one answer isn't. Tell me which one is which. Or I may give you a hint and say both answers are extraneous. So this isn't one you could solve graphically and get the extraneous answers even if you wanted to. The calculator can't give you the extraneous ones. Only you can get them by showing you the work. That's what I look for. Yeah.
Why do extraneous solutions exist if they're not like a real solution?
So it happens because we multiplied both sides by a variable. So it's the same thing that happened right here. When I multiplied both sides by a letter, that process in math can introduce an extra answer. But it's the only process we have to solve these kinds of equations algebraically.
Okay.
There might be other ways to do it, but they're not ways that I'm going to get into doing or showing. Yeah. We're trying to use what we already know to solve these equations. Quadratic formula, factoring, things like that. All right, so this is going to bring us into the last question. And I just wanted you to read it. It's back to the problem that we did about Sue driving in the car and taking the train. But the question they're asking is worded differently than the first one. after you read it, I just want you to tell me what's different about the wording.
It's an inequality.
It's an inequality, right? So that's the last thing we're getting to, inequality. They want the time for the trip to be less than 2.5 hours. Not equal to 2.5, not more than 2.5. They want less than 2.5. So we're going to solve it graphically, and we've already got like 75% of it done. We already put it in y1. We do have to change what's in y2. Okay. What am I going to change y2 to? It's not going to be 2 hours anymore. We want it to be 2.5. I'm going to hit graph. So again, there's the time it takes for her to make the trip. There's a mark at 2.5 hours. Okay, and what do you think I still want to find next?
The intercept.
I want to find the intercept. So it comes out to 34.88. Now I want to write the answer to the question they asked though. It says, at what possible rates could she travel at to complete the trip in less than 2.5 hours? If she travels 34.88, she will complete the trip in exactly 2.5 hours. So what does her speed have to be then? To do it in less than 2.5 hours. Yeah?
Any speed greater than 34.88.
Right, any speed faster than that. Because the faster she goes, the less time it takes. So don't say that her speed has to be less than that. If her speed is less than 34, it's going to take longer. Her speed has to be greater than that. Can it be greater than or equal?
No.
No. It doesn't say she can complete the trip in 2.5 hours or less. It says less than 2.5 hours. Okay, so in this case, x is greater than 34.88. Would it be 8.9? No, because the next one is a 0, so the 8 would stay rounded down to an 8. If you're going to round to the third, it would be 34.881. That would be your speed. Yeah, it's hard to see the 0 and the 8. It's kind of small. If I had done it like this, you would see better. Okay, any question on that one? All right. So when we solve them on the calculator, we'll try another one. But that's the approach we're going to do. Why? If this was an inequality sign, like a less than or a greater than, there's one thing that you have to be careful about when you multiply or divide that can happen.
Oh, flip.
When?
When it goes negative.
Right. If you multiply or divide by a negative, you're supposed to take the sign and flip it. Well, we multiplied both sides by x plus 2. Is x plus 2 negative or positive?
Positive.
Well, what if x was negative 10?
Well, yeah.
Then it would be what?
Whenever-
Then it would be negative. If x was negative 10, it would be like I multiplied each side by, I'd have a negative in there. So the problem with using this approach is when you multiply both sides by a variable, you don't know whether the variable is a negative or a positive. If you don't know whether you're multiplying by a negative or positive, you don't know if you should be flipping the inequality, which is why the method I taught you for equations, it does not work for inequalities. Equations, doesn't matter if you multiply by a positive or a negative. You're going to always keep this an equal sign. So that method is fine. Okay, but with inequalities, a little different. Just remember when you are solving an inequality, you may have to zoom in or zoom out to see something that's off the screen. Or maybe even something that's on the screen, but you can't tell enough detail, so you gotta zoom in. That's where most people mess up this, like on the homework or on the test. They forget to look for something that could be off the screen. Okay. Let me just see how many we have. Okay, so this is strictly just the calculator. You just gotta know how to use the calculator to do what we're looking for. There is a way to solve rational inequalities algebraically. I'm not going through how to do that with you. Okay, we're gonna stick to the calculator. Okay, so let's try this one. All right, so on the calculator, where do you think all of that is going to go? Why what? Can you be more specific?
Y1.
Yeah, let's put all that in Y1. And where's that going to go? It's going to go in Y2. Now, when you type it in, that numerator and denominator on the left side, that has multiple terms in it. In fact, it's three. Trinomial over another trinomial. You have to put it in parentheses. If you don't, it doesn't work. Okay, so this is how you type it in. In parentheses, 2x squared plus 6x minus 8 divided by 2x squared plus 5x minus 3. And what we're going to be looking for is where is this graph under the horizontal line that's 1. Okay, so where is that graph under the number 1? Okay, let's start with zoom 6, and then if we need to zoom out, we'll go from there. Okay, let's look at that graph and see what's going on. Okay, so we're looking for where the graph is under the number 1. Okay. Well, let's start with the middle part. Is the middle part ever under the number 1? No. So we don't even need to look at that. What we need to look at is the left part and the right part. Okay. What do you think about the left part? Does that part look like it's under 1?
Yes.
Does it look like it's staying under the 1?
Yes.
Yeah, it does. It looks like it's staying under it. It doesn't look like it's ever coming up and maybe crossing it. If you want to verify it, you can go to your table and plug in a number like negative 30. Have we talked about how to put the table set up on Ask? Yeah. So let's try negative 30.
How do you do that?
Second window. What do you think? Is it still under the number 1? 0.978? Yeah. It's going to stay under 1. So how far to the left? I want to describe that piece right there. How far to the left does that piece go?
Negative infinity.
Goes all the way to negative infinity. Now we have to figure out how high does it go? Does it just keep going to the right forever?
No.
No. It looks like I would say, looks like we have a vertical asymptote right there. Now I'm going to make the vertical asymptote pretty easy to find, that you don't really have to do a lot of algebra. Where does it look like the vertical asymptote is?
Negative 3.
Negative 3. If we type in negative 3, and it's a vertical asymptote, you should get the word error. Okay, and it is. So from negative infinity up to -3 describes this first section. And that is under the red line. Can I include -3?
No.
No, because that's an asymptote. So there's the first part, negative infinity to -3. Is there another part that looks like it's under the red line? Yeah, I would say this part right in here. My question is, does it cross the red line somewhere? It looks like it.
Yeah.
It might be.
It
Yeah.
does.
So what I'm going to do is I'm going to go back to my graph. I'm going to hit intersect. Move my cursor over near where I think it might cross. And it does. It crosses it at 5. Okay, so it crosses it at 5. So for our other interval, the highest that other section can go is right there. After that, you can't see it, but it does go above it. It's because the calculator doesn't have, infinite resolution. So, but it crosses it at 5. Now, can I include the 5 or not include the 5 based on the original problem? No. There's no equal to under that. So they don't want to know where the graphs are equal. They want to know where it is under. So no 5. And now I have to figure out how far to the left does that blue section go. Well, again, I think we have another vertical asymptote right there. How far to the left does it look like this blue section is going to go?
Maybe like 0.5.
Maybe like 0.5. So we could try 0.5. Right. Told you I was going to make the asymptote easy to find. It's not going to be like 0.573. Right? It's going to be like 1, 1.5. It's going to be an easy number to find. Okay, so what did we say the furthest left that it goes is? 0.5. Can you include or not include it? No, you never include an asymptote. And that's how you solve it. So if you pick an x value that's in the first interval or the second interval, you'll be under the red line. If you pick an x value anywhere else, you're going to be above the red line. Okay. Any question on that? And last one. So again, it's the same idea. Where's all that going to get plugged in? Y1. And when we type it in, we want to make sure we use what symbol? Yeah, if you got a numerator denominator with multiple terms, put it all in parentheses. So x to the 4th. And this is for any rational inequality you get in the homework. If it says solve algebraically and it's an inequality, you don't have to. We did all the inequalities graphically. The only ones we did algebraically were equations. Okay, so always do them graphically. Plus 2x squared plus 2. Okay, and where's my horizontal line this time? 15. So I got to set my y max. I'd probably go maybe 20. Okay, let me make sure I typed it in right. Yeah, looks good. And this time we're looking for where we are going to be above the 15. Well, that's not. That is, I think. All right, let's take a look at that.
Such an ugly graph.
Yeah, that one's not very nice. Okay, so we want to know where we're above the red line. Where are we greater than or equal to 15? Well, is the bottom part ever above the red line? No. So we don't have to worry about anything with that. Is the top piece ever above the red line? Yeah. How many pieces are above the red line? Two. I would say piece 1 and piece 2. Okay, so we're going to have 2 intervals. We have to figure out where piece 1, how far left it goes. Again, it looks kind of like we have a vertical asymptote. Maybe right there. Where does it look like the vertical asymptote is? 2. All right, let's try 2. So second table, if we plug in a 2, there you go. So 2 is the vertical asymptote. So what's the lowest number that you can pick for x and still be on piece 1? 2. You can only go as low as 2. And the highest you can go is where they cross, right there. So I'm going to have to do an intersect, and does the guess matter? Yes, it does. There's 2 of them. So be careful where you put it. Try, the best you can to put your guess kind of where I'm putting it, close to the left one. And I get 2.22. It's a little hard to get it, but it comes out to 2.22. Now I should check this before I go. Can they equal each other in this one?
Yes. Yeah.
Yes, they can. So what symbol should I have used after the 2.22? That one should be a bracket. I don't use a bracket on the 2 though. The 2 is an asymptote. Can never include that number. All right. Now I have to figure out where interval 2 starts. How am I going to get this point right there? Yep. Do intersect again. Again, this time, just put your guess. If you want to be safe, just move it way further to the right, and it'll definitely pick the one it's closer to. 2.68. Now, same question. Can I include 2.68?
Yes.
Yeah, the graphs can be equal in this case. And if we keep drawing that, how far to the right is that going to keep going?
Positive infinity.
It's going to just keep going to the right. It's just going to go higher and higher off to the right.
When you have access to a keyboard that could type the infinity symbol, is the standard right INF?
Yeah, you could write that. That'd be fine, yeah. I'll always make sure the button pops up for infinity. Okay, so we got through everything, which means tomorrow is just going to be a review day. And then we'll just go over the homework, and that'll be it. Okay, so that's the homework for tonight. So 1 through 13 odd, and then 20, 22, 24, 28, and 31. Remember, any ones that tell you to solve algebraically, if it's an inequality, you do it on the calculator. You don't have to solve algebraically if it's an inequality. Because I didn't teach you how to do that.